Direct current DC and alternating current AC are two types of electrical current used in circuits. The primary difference between them lies in the direction in which the electrical charge flows. In a DC circuit, the electric charge flows in a single, constant direction. This type of current is typically produced by sources such as batteries and solar cells. DC is commonly used in low voltage applications like electronic devices and automotive systems. In contrast, AC circuits have electric charges that periodically reverse direction. This alternating nature of the current is characterized by its frequency, measured in hertz. In most countries, the standard frequency of AC power supply is either 50 Hz or 60 Hz. AC is generated by power plants and is the form of electricity delivered to homes and businesses via the power grid. The ability of AC to be easily transformed to different voltages using transformers makes it more suitable for long-distance transmission that reduces energy losses. The table that you see here highlights the key differences and similarities between direct current and alternating current electricity in circuits. Direct current circuits are commonly used in applications where a stable and constant voltage is required. Examples include battery-powered devices such as smartphones, laptops, and electric vehicles. DC is also used in solar power systems where photovoltaic cells generate DC electricity, which is then either used directly or converted to AC for grid compatibility. Additionally, DC is employed in low voltage applications like LED lighting and electronic circuits and consumer electronics, as I mentioned earlier. Alternating current AC circuits are predominantly used in residential, commercial, and industrial power distribution systems due to their efficiency in transmitting electricity over long distances. Household appliances such as refrigerators, air conditioners, and washing machines operate on AC power. AC is also used in large-scale electrical systems like power grids that I mentioned earlier, where transformers can easily step up or step down voltages to minimize energy loss during transmission. The choice between DC and AC circuits depends on the specific requirements of the applications, such as the need for stable voltage, efficiency in transmission, or compatibility with existing infrastructure.